Assalamu alaikum guys. Alright, so basically in this lecture we are gonna do AS Physics 9702 paper 1-2 of May-June 2010. Duration of this paper is 1 hour. This lecture we are gonna do the first 10 MCQs from 1 to 10. Okay, so let's get started. Okay, the first MCQ. A micrometer screw gauge is used to measure the diameter of a copper wire. The reading with the wire in position is shown in figure in diagram 1. The wire is removed and the jaws of the micrometer are closed. Okay guys, one thing to note over here is that the jaws are always closed in order to check for zero error. Okay, this is one important keyword to understand. Then the new reading is shown in diagram 2. Alright, so we have to check out for zero error in diagram 2. What is the diameter of the wire? Alright, so first of all, the sleeve or the main scale and then the circular scale. We have to check out the readings. Alright, so 1 and 2. And then there is a 2.5 as well. So on the main scale reading is 2.5 because there is a line below the middle line as well, which represents a 0.5 division. Alright, so therefore the reading on the main scale is 2.5. How about the reading on the circular scale? Okay, let's try reading this out. So it's turning out to be 9. Alright, so the reading on the circular scale is 9. This would mean that the total diameter that is represented is 2.5 plus 9 divided by 100. Okay, 9 is always, the circular scale reading is always divided by 100. The answer to this that we get is 2.59. Okay, but guys, one thing to remember over here that this is not the final reading because this scale contains a zero error. Okay, how does it contain a zero error? Let's see. Okay, the reading that we get on the zero scale is, or the main scale is 0, but the reading on the circular scale is 14. This tells us that the zero error is for 0 plus 14 upon 100. There is a zero error of 0.14 millimeters. Okay, now to get the actual value, we are going to subtract the zero error from our final result. Sorry, from our measured value to get the correct value, which turns out to be 2.45. So answer option B is correct. Okay, moving on to the next part. SI unit for the potential difference is given in the base units by, since we know that by definition volt is the work done per unit charge. Sorry, this is charge. Work done per unit charge. Okay, so work done is actually energy, which is force multiplied by displacement divided by charge, that is basically Q. Alright, now in this formula, we know that force can be written as mass into acceleration multiplied by the displacement divided by charge. Guys, remember that charge is also equal to the product of current and time. So we can place current and time beneath it in the denominator. Now, replace the symbols by their SI units and you'll get your answer. Mass is kg. The SI unit of acceleration is meters per second squared. The SI unit for displacement is again meters divided by SI unit for current is amperes. SI unit for time is seconds. Okay, so let's get our final result. kg, meters times meters is meters squared. Seconds will go up and it will become s minus 3 because minus 2 will get a minus 1, right, because it will go up. And amperes will go up and get an reciprocal sign as well. We'll get a negative and inverse. So let's check out the answer option that resembles this answer, and it's option D. Okay, so let's move on to the next question. Okay, MCQ number 3. A student finds the density of a liquid by measuring its mass and its volume. The following is a summary of his measurements. Okay, mass of the beaker is given. Okay, its absolute uncertainty is also given for the mass balance. Then mass of the beaker plus liquid is given. Then the volume of the liquid is given. He correctly calculates the density to be 5 grams per cm cube. What is the uncertainty in this value? Okay, what is the uncertainty in the value of the density? Right, so basically density, by the basic definition of density, is density equals mass upon volume, mass per unit volume. All right, this is the basic definition of density. First of all, let's calculate the mass of liquid. Okay, to calculate the mass of liquid, you have to subtract this mass, which is given below, and this mass. Okay, basically you need to find the difference in between them. You have to subtract the mass of the empty beaker from the mass of the full beaker. Okay, in doing so, what you do is you uh, in doing so, what is going to be the total absolute uncertainty? Okay, whenever we add or subtract two measurements or two values, their absolute uncertainties get added up. So 1 plus 1, this is the absolute uncertainty in the value of mass, 2 grams. All right, now you have the absolute uncertainty of mass. How about finding the absolute uncertainty of volume is given over here? Okay, now all we need to do is we need to find the we need to find the actual uncertainty in density. Okay, whenever two quantities are being divided or multiplied, their fractional uncertainties get added up. We know this from our theory. Okay, so the fractional uncertainty of density must equal the fractional uncertainty of the mass, which is actually the uncertainty of mass divided by the measured value of mass, plus the uncertainty of volume divided by measured value of volume. This is the fractional uncertainty in volume. Now let's plug in the values and get our result. Okay, we need the value of delta D. We have the correct actual value of D, which is delta G upon 5, which equals, what is the value of change in mass? We calculated it to be 2. What is the actual value of mass? Okay, what is the mass of the water? 70 minus 20 is 50, right? Mass of the liquid, basically, not water, liquid. And plus, what is the absolute uncertainty in volume? It's 0.6 divided by, what's the actual value of volume? It's 10. Now use your simple math, and the answer you get is 0.5 grams per cm cube. So B should be the correct answer. Moving on to the next question, number 4. An ion is accelerated. Okay, ion is a charged particle, is accelerated by a series of electrodes in a vacuum. A graph of power supplied to the ion is plotted against time. What is represented by the area under the graph between any two times? All right, so power against time. Let's assume this is the graph of power against time. What will the area under this graph represent? Okay, the area under the graph would actually represent area under the graph. Let's assume if this is a triangle, the area under the graph is a triangle. So it's actually the product of power and time. Okay, what is equal to the product of power and time? Isn't it the energy? It's energy, right? The product of power and time is energy. So if the product of power and time is energy, actually for a triangle or for a rectangle, this is the product, this is the result that you get for a rectangle. If the graph is basically a horizontal line, then the area under the graph is going to be the power on the y-axis and the time on the x-axis, and the product of them. Okay, in this case as well is going to be half into power into time, or in any case the SI units are going to be power into time. Power into time by definition we know is equal to the energy, so it's actually going to be the energy. Now let's see which option has energy. The change in kinetic energy of the ion, yes, this is energy, this can be a possible answer. Average force, no. Change in momentum, no. Change in velocity, no. So only answer option A is correct, because this matches the SI units of energy. Let's move on to the next MCQ. Number 5. A diagram shows a square wave trace on the screen of a CRO. A grid of 1 centimeter covers the screen. The time-based setting is 10 milliseconds per centimeter. This tells us that each centimeter on the x-axis, time base is always labeled on the x-axis. Each centimeter of the x-axis represents a time period of 10 milliseconds. What is the approximate frequency of the square wave. Right. So basically for such questions, now we know the formula of frequency equals 1 upon time period. Time period is a time taken for the one complete cycle of a wave to complete. Right. Now let's look at one time period. Okay, from where does the okay, how to identify the where the time period or where one complete cycle of a wave completes. So basically we can't actually measure one complete cycle, but we can take an average value. What we do in this case is that we take an average value, we add all of these. Okay, how many boxes? One, two, three, four, five, six. Okay, six boxes would mean 60 milliseconds. Since each centimeter, each box represents 10 milliseconds. 60 milliseconds. And in this 60 milliseconds, how many waves do we have? Okay, so using unitary method, we'll calculate the time period of one wave and then use it to calculate the frequency. Now, let's count the waves. Okay, so now how to count the waves? Basically, you're gonna start the counting from one point, and then as soon as you reach back at that point, one cycle of the wave will complete. Okay, now if I'm starting from here, I'll go up, and this is where the first cycle completes, because immediately after this the horizontal part of the graph starts. Okay, so this is how your first wave completes. Then 2, 3, 4, 5, 6, 7, 8, and half a wave, 8.5 approximately. All right, so if 8.5 waves represent 60 milliseconds, then how many milliseconds does one wave represent? Because we are actually doing this to calculate the time period of one wave, the time taken for one wave to form, which is actually the time period. And x is gonna be 60 upon 8.5, which will give us an answer of 7.1 milliseconds. Okay, so this is the time period of the wave, 7.1 milliseconds. Now using this time period, we are going to calculate the frequency. Frequency is equal to 1 upon time period, right? So 1 upon 7.1, and this milli millisecond has to be converted into seconds, and this gives us an answer of approximately 141 point something, which can be rounded off to 140. All right, two significant figures, so bravo would be the correct answer in this case. Moving on to the next MCQ. All right, in this case, a vector quantity is resolved into its perpendicular components. The angle between these components is theta. The angle between x and the vector v is increased from 0 to 90. Okay, this angle between the components x and v, okay, x and v, this angle is increased from 0 to 90 degrees. Okay, so if it is increased from 0 to 90 degrees, this would actually mean if the value of if this theta is increased from 0 to 90, this would mean that this v initially when it was theta was 0, so v was actually equal to x, right? V and x were equal, and y in that case was 0. V and x were equal and y in that case was 0. Then as the value of this theta increased from this 0 to 90, gradually the value of x kept on decreasing, and the value of y, it kept on increasing because its horizontal distance, its horizontal component now starts shrinking, and its vertical component, because it is gaining height, starts increasing. So what happens in this case? The x actually decreases and y increases, so C should be the correct answer. Let's move on to the next MCQ. Number 7. The product of pressure and volume have the same SI base unit as? Okay, if we multiply pressure, which is basically pascals, by volume, which is meter cube, what SI units do we get? Okay, first of all, we need to break this pascals into base units. Okay, pascals is force per unit area, right? Force upon area. Area can be written as meter squared, and it will get the product of meter squared and meter cube. All right, they'll cancel out. Okay, so the thing that we are left with is force multiplied by the meters. Basically, force multiplied by displacement or force multiplied by distance. Basically, Newton meter is left, and Newton meter we know that energy or work done is equals to force multiplied by distance. So these are the same as energy. Answer option A is correct. Then moving on to MCQ number 8. Okay, a small steel ball falls freely under gravity after being released from rest. Okay, which graph represents the best represent the variation of the height of the ball with the time t? Okay, now if this ball is released and now it's going down. Okay, this is actually a distance time graph, so its gradient will represent the velocity. Initially, its velocity is gonna be zero because it is dropped. It is dropped from rest. So basically, initially its gradient is zero. This is a graph having a zero gradient, and this is a graph having zero gradient. All right. Now, after that, its gradient keeps on increasing, increasing, and reaches a maximum value. All right, after the time passes. But one thing to notice over here is that this age, it actually represents the height of the ball. It represents the height of the ball above the ground. So this height of the ball above the ground, as the ball approaches Earth's surface, this height of the ball will decrease. It will not increase, it will decrease. Since this height of the ball decreases, B should be the correct answer. Now let's move on to the next MCQ. The diagram shows the velocity time graph of a vehicle. Okay, the vehicle moves at 4 meters per second speed. Okay, this is its initial speed. Then it begins to accelerate at this time. And then what is its acceleration at the time of 3 seconds? Okay, 1, 2, 3. Okay, this is 3 seconds is the time. All right, they're asking us acceleration at this time. Okay, for this question, actually, we need to calculate the gradient of this tangent to this curve. All right, so how to calculate the gradient of the tangent to this curve? Okay, so this is how the gradient will look like. All right, so passing through this point at the time 3 seconds. All right, 3 and 6 at the time 3 seconds. The y-axis value of velocity is 6, and it passes through 6, 10 and 0, 2. Right, so we can then use any of the two values to get the gradient of this tangent, because gradient of this graph actually represents acceleration, because this is a velocity time graph. Its gradient represents acceleration, and acceleration in this case I'll take 6, 10 and 0, 2. Okay, so 10 minus 2 upon 6 minus 0, which turns out to be 4 upon 3, and this is approximately 1.3. So C is the correct answer. Now MCQ number 10. The diagram shows two identical spheres x and y. Initially x moves with velocity v directed towards y. Y is stationary. The spheres collide elastically. Okay, elastic collision means no loss of energy, no change in kinetic energy, no change in any form of energy. All right, what happens? Okay, x is moving with the velocity of y, and y is stationary 0. Okay, what happens? Okay, x, it moves with the speed 1 upon 2v to the right, and y moves with the speed 1 upon 2v to the right as well. Well, will that happen? Well, let's check out the other MCQs. uh, okay, moves x moves with the velocity of v to the left, and y remains stationary. Okay, x moves with a velocity of 1 upon 2v to the left, and y moves with a velocity of 1 upon 2v to the right, and x stops and y moves with a velocity of v with a speed v to the right. Guys, one thing to remember from your theory is that these are two identical spheres. Okay, whenever two identical spheres collide elastically, such a collision is called perfectly elastic collision. Okay, elastic collision between two identical spheres. Okay, they have equal masses, so they are identical, is perfectly elastic collision. And in perfectly elastic collisions, what happens is that the sphere which is carrying its momentum towards the other sphere, it transfers all of its momentum to the other sphere. All of its energy has been converted into the energy of y, into the kinetic energy of y, and y starts moving with the same kinetic energy as x. And x, since it has lost all its energy, so its velocity becomes 0, whereas the velocity of y becomes equal to the initial velocity of x, because it has now gained all its energy. So the most appropriate answer is option number D. Okay, guys, if this x would have been massive, okay, it would have been massive, then what would have happened is that both x and y would have started moving in towards right. And if x uh, would have would have been lighter, then it would have rebounded in the opposite direction. But since their masses are equal, so perfectly elastic collision takes place. Perfectly elastic collision takes place, and in such circumstances, the velocity interchanges. All right, even if this could have been a condition if these two spheres were moving towards each other with a certain velocity, although their masses are the same. But if they would have been moving towards each other, for example, this sphere from the left would have been moving with a velocity of v, and sphere from the right would have been moving with a velocity of u, then as a result of perfectly elastic collision, what would have happened is that they would have interchanged their velocities again. Okay, same is the case over here. So this is an example of perfectly elastic collision. Thank you so much, guys. The next 10 MCQs are in the next video. All right.